The last two examples involve probability of a multiple pick situation, but we're going to make the rules either with replacement or without replacement. Okay, let me say that. And let me say one other thing about this with replacement, without replacement thing. We always assume we got what we wanted on the first pick. Okay, anytime you pick something more than one thing, and there's no replacement happening. So in other words, you're pulling it out, you're looking at it, you're going to set it aside. You're going to assume that you got what you were looking for. So if you wanted a red marble, you got a red marble. If you wanted a white marble, you got a white marble, whatever color we're dealing with. All right? So we have an urn here that contains 3 black marbles and 5 white marbles, and a marble is being drawn at random and being replaced. So in other words, I reach into the urn, I can't see the marbles, I pull one out, I look at it, see what color it is, and then I drop it back in, right? So it's replaced. And then the second marble is randomly drawn, and it says, what's the probability that both marbles are black? All right, so let's look at probability question A. All right, so probability that we get black on the first pick, black on the second pick. Does anybody recall how to do multiple pick probability?
You
Parker.
Take how many marbles and you add them up, and that's the bottom bracket.
Okay, so how many marbles go on the bottom, Parker? 8.
And 3 on the top.
3 on the top.
And you multiply by the same fraction.
Okay, and we're multiplying by the same fraction because in part A it's telling us we want the probability that both are black and we're replacing. So, in other words, I have this urn, it's this decorative vase here, right? I got these 8 marbles in it, 5 white and 3 red marbles. And they feel the same, they weigh the same, they're the same temperature, the only difference is the color. I can't see to know what color they are to reach down in there. So I reach down in there, grab one, I look at it and it's black, right? Because I always assume I picked what I was looking for. So I got a black one. Chance of getting a black one on that pick was 3 out of 8. I drop the marble back in the urn, so there's still 8 marbles, there's still 3 black marbles, so the chance of getting a black marble in the second pick is also 3/8. And as Parker told us, we're going to multiply those fractions together, so 9 out of 64. For a replacement situation, 9 out of 64 is the chance of getting both black marbles. All right. Now looking at question B, question B in red, I'll do that down here. If the first marble is not replaced before the second marble is drawn, what's the probability that both marbles are black? So we're looking for the same probability, right? Probability is black on the first pick and black on the second pick. Okay, the first pick, how many marbles are there?
8.
How many are black?
3.
So on the first pick, same issue, right? We have 3 black marbles, 8 of which are 8 marbles, 3 of which are black. All right, but we're not replacing. So what kind did I pick?
Black.
I picked a black marble, right? So I picked a black marble out and I set it on my desk, and now I got an urn with how many marbles in it?
7.
How many are black?
2.
2. So my second pick here, after I don't replace, is only going to have 7 marbles to pick from, but only 2 of those are black. So we've decreased both numbers. And notice that 2 and 8 reduce. I do recommend reducing fractions before multiplication. They can be in the same fraction, different fractions, whatever, but if a top number and a bottom number have the same factor, you can reduce by that number. 3 times 1 on top is 3, and 7 times 4 is 28. So the chances are 3 28ths. Which one do you think is bigger? Anybody know? 964 is 3 28ths. What, you think the first one's bigger? Probably, right? Because the chance of getting a 3/8 is probably going to be better than 2/7, right? Because there's now fewer black marbles, the same number of white marbles, the chance of getting white's bigger. The way you know which one's bigger, it's real simple. If you just type in 9 divided by 64 equals, and 3 divided by 28 equals, the bigger decimal is the bigger number. So 14%, 11%. So the chances of getting it on the replacement is a better probability than getting it without replacing.